So just a bit of background. The current warm homes policy, the Labour government, their aim is to upgrade 5 million homes, have a net zero achieved by 2050 for the UK, and progress towards statutory fuel poverty target by 2030. The performance targets for the funding of Warm Home Social Housing Fund and local grant are EPC Band C for treated homes. The schemes do target low-income households and specifically social housing. And there's some details on the right there about what the grants are aimed at, who they're for, and what they're targeting. So, what is PAS 2035? It's the British standard for retrofitting dwellings. It was first published in 2019, and it outlines how retrofit projects should be managed and delivered. PAS 2030 is a kind of, the 2030 and 2035 go together. PAS 2030 is for installers, and PAS 2035 is the overarching retrofit standard, and it is like a methodology for managing projects with minimizing the risks to occupants and owners of properties. As I mentioned, PAS 2030 is the standard for the installation of measures and the commissioning and the handover of those energy efficiency measures. So explaining to the occupants and to the landlord of the property what the measures are, how they need to be managed and serviced, etc., and their operation. There is another standard called PAS 2038, which is for retrofitting of non-domestic buildings. There's a slight misunderstanding in terms of the numbering. Obviously, it sounds like it's referring to years, but it's not. It's just a sort of annoying coincidence. I should mention that we are in a transition period at the moment between an older version of PAS 2035 and a newer version, which is called PAS 2035 2023. It you can use PAS 2035 2023 now, and as of 30th of March this year, the earlier version of PAS, the 2019 version, will no longer be available. So all projects that require it must use the 2023 version. Briefly at the bottom there. So basically what it's doing, its idea is to give a holistic approach to the building, regarding it as a system of elements, to do with the interfaces of different fabric elements. So the walls, the junctions, between walls, floors, roofs, etc. That's often where we have problems with moisture, condensation, mold, etc., because it is a high risk of thermal bridging and cold spots, which attract moisture and condensation. The occupants, obviously, occupant rates, occupant behaviour plays a big part in also in terms of the risks around retrofit. Basically, the point, it shouldn't be regarded as a set of elements, separate elements that are independent, but actually it is a system of all those elements. They all have a greater, or sometimes less, but mainly interconnected effects one to the other. This diagram gives you a sort of idea of how PAS 2035 delivery operates, and this you will find in the PAS document, which is available from BSI. If you Google BSI and PAS 2035, you can download the standard, the 2023 standard, free. And in there you'll find this diagram. So at the top, we're looking at this sort of inception of a retrofit project. So we're looking at putting together engagement advice, thinking about preliminary considerations like the targets, what it is you're trying to achieve, and onboarding all the different parts of the organisation that need to be involved. Next, we need to engage retrofit coordinator, who in turn will be commissioning a retrofit assessor, designer. The evaluating role is normally something that the retrofit coordinator will do, but not necessarily. There might be an independent evaluator. We go into a dwelling assessment, that's the retrofit assessment, including ventilation. And if there's any, if the building is of a traditional, sort of listed or conservation area property, then you would probably have a significance assessment. So that operates under this British standard here, BS 7913, and you would possibly engage someone with a traditional or protected building expertise at that stage. Following that, you would put together down in the next stage here an improvement option evaluation with a medium-term improvement plan. That would be the retrofit coordinator would do that on the basis of the assessment. That would be approved by the client. Then we go on to retrofit design. Again, something overseen by the retrofit coordinator, who acts as a kind of end-to-end project manager on this. And then we get into the installer part of this. So they would work with the approved design, and they would be responsible for the pre-installation building inspection, then the installation, then the testing, commissioning, and handover. So that section highlighted in the sort of darker rectangle here, that is covered by this PAS 2030 standard for installation of measures. Following that, there's a monitoring and evaluation to make sure that the retrofit has been kind of performing as it was designed, and that might involve just looking at energy meters, energy consumption, talking to the resident about levels of comfort, operation of the ventilation, maybe new heating system or controls, that kind of thing. And if further investigation is needed, then that would be escalated following that stage. So just thinking about how programs are delivered, again, is working from illustration from the PAS standard. As you can see here, the source is PAS 2035, 2030, noted at the bottom. So, and we're literally looking at, what's required for all buildings, traditional or protected buildings, high rise greater than 11 meters, system builds, so non-standard, and any further requirements. And this basically, it gives you all the different steps that I was mentioning in a little bit more granular detail, and where you might need to give additional consideration depending on the type, age, cultural significance, location, etc., of the building. You would be required to do, additional kind of measures or assessments or evaluation work. And again, this next slide just goes through the following steps. So, just going through a couple of these examples. So you might have, for installation and quality control, you might be thinking about doing sort of toolbox talks with installers if they haven't worked on PAS 2035, even if they have worked on PAS 2035 projects before, a reminder about the kind of quality of installation that's required, what the overall project aims are, and also, where possible, kind of recording anything significant, whether it's the finished install with photographs or whether maybe there's certain kind of challenging elements of the install. It's worth having photographic evidence of that. So moving on to requirements. So complying with PAS 2035 and the associated PAS 2030 document. You need to comply with it in order to, well, you need to be compliant with it in order to release funding associated with certainly government-funded retrofit projects. This is the whole idea of it, is to ensure that we have good quality assessment, design, installation, and follow-up kind of with residents after retrofit, so that we get the carbon savings that we're paying for, hopefully improved levels of comfort and reduce energy costs for residents. The retrofit coordinator and retrofit installers must also be registered with Trustmark through an accreditation scheme or an accredited scheme, and you can find details of that on the Trustmark website. And a certificate of compliance must be lodged with Trustmark for the completed retrofit, but all along there are other required documents for the projects which need to be lodged with Trustmark from the instigation to completion of the project, and that is the responsibility of the retrofit coordinator. They're the person who acts as the kind of project manager end to end to be compliant with the PAS 2035 standard. That process of uploading your documents to the data warehouse is known as lodgement. Here are a few of the kind of key documents that are required as evidence to be saved with saved in the Trustmark data warehouse. So retrofit objectives. What were the initial aims of the projects that you were targeting? Was it fuel poverty? Was it EPCC? Was it addressing high levels of mold and damp? All of the above, etc. Option evaluation. So looking at the retrofit measure options that could be considered, and obviously, given budgets, there is and other maintenance and ongoing maintenance and upgrading programs that might well be pertinent to particular housing associations or landlords. They will. The most cost-effective way is obviously to tie in retrofit projects with ongoing programs of works in where you can. Other things that you would be submitting ventilation assessments wherever we're doing retrofit work, and draft proofing, putting in new windows, maybe solid wall insulation. Generally, you can expect that the background ventilation or uncontrolled ventilation is being reduced. So we need to be thinking about putting in some ventilation so that we actually have fresh air for occupants, but also if we've got families who are there who are doing a lot of washing, cooking, etc. There's a lot of moisture in the air when people are cooking, and if you have lots of people maybe bathing for young children, etc., you do need to have a suitable level of ventilation to cope with that in order to ventilate out that moisture so that it doesn't cause problems of damp and mold. The retrofit delivery plan, what works are being done, how and with what materials and products and systems. The medium-term retrofit plan, so how you would be looking at staging, maybe the complete upgrade of the home. It's unlikely you'll be doing a whole house retrofit at one go, and certainly with the funding, government funded schemes targeting EPCC, then generally it's best cost improvements to get to EPCC. However, if you, as a landlord, wish to go to B or A or whatever, you might target a particular SAT value, then that retrofit plan would be used to establish the sequence of improvements that you would do in a sort of stepped retrofit in order to get there. Certificate of compliance, obviously that's confirming that the works have been done in line with the standard, and then a monitoring and evaluation plan is all about assessing and understanding that the retrofit is performing as it should. So just a quick overview of the 6 stages of PAS. Here we're back to the diagram of the sequence of events, but in a way we can break this down into 6 stages. So we've got the intended outcomes, the risk assessment, dwelling assessment, planning and design, installation and handover, and then the monitoring evaluation follow-up. As I mentioned previously, the monitoring evaluation, if there are concerns that the retrofit, the retrofitted property is not performing, or something is in terms of energy use or comfort or occupant feedback is not right, then the retrofit coordinator, because it's them who's likely to be doing this evaluation and monitoring work, would then recommend possibly further studies of energy use or understanding of whether occupant behavior has changed, and then maybe investigating if systems have been correctly installed, and you might go on with further investigation if you are finding it hard to identify what the issues are, but that's part and parcel of that final stage. As I mentioned in the first step, we're looking at the intended outcomes, what you want to achieve. Maybe it's EPC Band C or a specific heat demand, or is there a maximum spend, or how many properties are you doing? Is there just one set of outcomes that you're focused on, or are there more than one set? Do you have a single archetype, or a finite number of archetypes, a set of archetypes that you have and are targeting? Do you need to generate a plan for each property, or are there only 3 archetypes, and therefore initially a plan would be suitable for focusing on a significant sample of those 3 archetypes, let's say. Certainly in the latest PAS, when we're putting together retrofit plans and costings and all that for funding, we can look at a significant sample of archetypes. Once you've got the funding and you're into delivery, then you do need to have a retrofit assessment done of each and every property, because obviously we know that although you can have properties of the same archetype, actually over X number of years with different occupants, the internal layouts might have changed. It could be that requirements of properties by different landlords have happened in stages, and they have different heating systems, they have all sorts of differences which become apparent and significant once we want to retrofit. Oops, sorry, let's go back. So step 2 is the risk assessment. So just to mention, in the earlier version of PAS, the risk assessment process focused on identifying a risk path. a risk path A, B, or C for projects, and that was assessed using a set of 5 criteria. So the criteria were number of dwellings in the project, number of measures per dwelling, technical difficulty of the most difficult measure you were doing. So for instance, external wall or solid wall insulation was the maximum risk, and that dictated the risk pathway of the whole project. The other factors were a combination of measures. Particular combinations of measures were seen to be higher risk, and then obviously the last was relating to the construction and build form. Again, some would be higher risk, so any listed building or conservation area would also be a higher risk. In the latest version of PAS, and the one that we need to be using after the 30th of March this year, that process, the risk assessment process, has been standardized. So you basically it's aligned with the risk path B for all projects, because this process of identifying risk pathways per project was found to be more problematic than it was worth, and actually this idea of standardizing it is seen as something to simplify the process without compromising the idea of the quality of the retrofit. And that last note, the result is a basic building assessment, but with enough additional data to create an accurate RDSAP, SAP or Passive House Planning Package. That's what PHPP stands for, energy model. And it's that energy model that is required to demonstrate you achieving, EPCC, for instance, through the installation of particular measures. So just to cover this a little bit more, risk path B, this was one of the 3 risk pathways that explained very briefly there. On the left, risk path B is the one we're going to be using for PAS 2035-2023. There's a note here saying that the air tightness testing is no longer normative part of the assessment, but it can be recommended if the retrofit assessor or retrofit coordinator deems that there is a higher chance of risks around air tightness. So you could be recommending that rather than it being a normative requirement. So onto retrofit design. So this matrix here on the right is also in, I think, PAS 2030, I believe. It actually says the source is PAS 2035. I think they're kind of both linked documents, to be honest, in the download. So this matrix you will find in there, and what it does, it basically shows the kind of risks around combining different measures in the same dwelling. So you basically have the same measures running diagonally down here and along the top, and where you're showing cells which show the combinations of different measures. Green illustrates that there's no interaction and therefore minimal risk. The yellow spaces show that they do connect physically, but again, not a kind of high level of risk around that, but something to recognize. Orange is where these measures interact in other ways, and red is showing incompatibility. So the dwelling assessment, retrofit assessment data is used to support the development of the improvements, and you might want to do this in STAP, Standard Assessment Procedure, or PHPP, Passive House Planning Package, because they're more detailed than the RD SAP, that's reduced data SAP behind the kind of government standard EPC certificate. The conversion can be made by your energy modeling specialist. So generally, if you've got the RD SAP including the background data, then you can convert that into the SAP or PHPP model. The dwelling assessments are undertaken, as I said, by a retrofit assessor. So these have been people that have been trained as a domestic energy assessor, but they also need to do an occupancy assessment, and they also need to be looking at any underlying issues with the building, which might relate to rising damp or penetrating damp from rainwater goods or leaks or anything like that. Any evidence of mold and damp in the property would need to be recorded. They might recommend additional testing, such as thermal imaging or air pressure testing, if they see that as a risk. It's a little bit more involved as an assessment than an EPC, and takes about a half day to do. So you can see the costs of doing this in terms of preparing your application for government funding would be prohibitive if you were required to do assessments on every building, hence the allowance to work with archetypes. So as I said, you would end up doing a kind of sample of assessments on the archetypes of properties that you're putting into your bid. So planning and design. Basically, this is the step where the retrofit coordinator would use that information from the assessment to produce a medium-term produce an improvement option evaluation. So this is looking at the measures options for that particular property. And you would then review the upgrades via the risk table, considering costs, disruption, risks, whether you need planning, how appropriate they are, and in light of the kind of initial aims of the project, how far down, given your budget, you are going, and therefore what kind of measures you would be looking at to achieve those aims. That would all be part of the medium-term retrofit plan is something that is really about the whole house retrofit, and ideally what you would be able to do to that to do a complete retrofit, but that would be agreed with the client and explained to the client. And then following that, you would have a retrofit designer draw up for the chosen installation appropriate design work for that. So for instance, if you're doing internal or external wall insulation, you would need to be thinking a lot about the kind of interfaces of elements, the risks around cold bridging, overhang of eaves where you have the external wall insulation meeting the roof line, how you're going to accommodate the change of rainwater goods, anything else attached to the outside wall, possibly moving windows within that into the insulation layer. Lots and lots of elements that you would need to consider to ensure that the new measures are fit for purpose, and where they are exposed to the weather, that they're going to prevent any kind of water ingress behind insulation or into the property or into the walls. External wall insulation is the one that is most likely to require any planning. Some instances it's perceived as permitted development, the same way that solar panels are in certain places. if you've got buildings, as I say, conservation areas or listed, then obviously you would be needing planning permission, but it's not always permitted development, so you do need to check. This is well, in terms of the improvement option evaluation, this helps to determine which are the best measures from a carbon saving perspective. It helps to identify how to get to EPCC or higher, and the combination of measures that go well together to get there from best value. This is an example of a table performer that could be used for this, and this comes from the Retrofit Academy, that provide lots of training options for different retrofit qualifications. Medium-term improvement plans. Again, this is an image taken from the Retrofit Academy's documentation. So in most retrofit projects, we won't do the whole house retrofit. So this helps us to know how we can get from our starting point to our objective, whether it's net zero, EPCC or B, over a period of time. And this can help us align future retrofit programs alongside planned maintenance programs. So where maybe you have planned maintenance or replacement of windows or roofs or other things, maybe kitchens or bathrooms, it might be a good time to tie in with retrofit works from the point of view of access to walls, or even if it's aligning with you know, the works being done and minimizing the number of visits and the disruption to occupants, etc. So should always try and certainly be aware of other programs, maintenance, repair programs that are going on, and trying to align those. So the next stage is the installation. And as I mentioned, installers of all retrofit measures must be PAS 2030 certified for their specialist fabric measures, or MCS, that's Micro Generation Certification Scheme. MCS certified for low carbon technologies such as PV, so photovoltaics, or air source heat pumps or heat pumps. And the certifications should be checked by the retrofit coordinator. The main role for the retrofit coordinator is to maintain oversight of the works. If there's a change of materials or products, this needs to be approved by the retrofit coordinator. If things like this are changed without their consent, that could have an impact on the contractor in terms of payment, in terms of or timing of payment. So you know, where changes need to be made, then the retrofit coordinator must be part of that process. Involved in the commissioning, or at least check that certificates and see that items are working on site. They need to be involved in handovers too. And that's all part of the retrofit coordinator ensuring PAS compliance. So this is the last step, is the monitoring. This is this should be carried out by the retrofit coordinator acting for the client. So quite often in projects there might be a retrofit coordinator appointed by the contractor. They certainly employ them just to know that they're being compliant at different stages and understand what compliance means. Quite often part of their service will include providing a retrofit coordinator for the project, which can be, you know, tempting from the client's point of view if they don't have resource or a limited budget to be able to do this. But actually an independent retrofit coordinator working for the client and resident is really where they should sit. So, as I say, certainly the monitoring and evaluation needs to be done from a retrofit coordinator working from the client for the client. So some riskier projects may need a more focused monitoring and evaluation stage. So if issues arise, then they may need to be evaluated in terms of an advanced or intermediate approach. Obviously, this depends on the kind of significance of the buildings, whether they're regarded as you know, in having technical difficulties associated with their structure, because they're non-standard build type, or a very local and historic build type. You know, whatever the reasons, then you might be required, to just have a more involved monitoring and evaluation process. It might be that it's not just about the performance of the systems, but perceived risks to the buildings, short term and long term. So just a final note about further resources through RISE. These are a few of the kind of pertinent masterclasses and toolkits which you can do through the RISE website. Also, there's a note about some new CPD accredited activities there. There's a sort of resident engagement boot camp. So these details you can find up on the website, and I believe this presentation is going to be shared with everyone who's on the call as we are proceeding now. So that's the end of the session.